Hi, everyone. Welcome to the next chapter in AI. Today, we are going to talk about lasso regression. It is used in conjunction with your loss function or your cost function. It is used during your training data when you're training and testing your model. Okay, it is used during that phase of machine learning. What what we're going to talk about, what is lasso regression, what is the formula of lasso regression, the limitations, or rather where should we use it, the limitations of lasso regression or where we should not use it, and also we will see in the end a sample Python program which shows how to use lasso regression in Python, like which library to use it. Okay, first the concepts. So basically, when you are creating a model, a machine learning model, what do? You first use the training data, you train the model, and then you test the model. So use a formula, or different formulas are there for linear regressions. Okay, so that is what you use, linear regression. Now, there is one big problem with linear regression, which comes when the number of factors that are used in the model, the factors or the features that are used in the model are a large number, or rather is a large number. There are a large number of factors which are used. Hence, lasso regression comes in, okay, which prevents overfitting of the model. It simplifies the model. Now, how does it simplify? When I say simplify means it makes it simple. So basically what it does is it tries to study which features or which factors are least important uh, for the model. And then it just deletes that factor. So let's say if there were 50 factors and two were not that important in predicting, then it will drop those two features. So then you're left with the 48 features for your model to work on. Okay. So that's how it shrinks the coefficients and chooses the important factors, like factors which really, really affect the model, the prediction of the model, the value of the prediction, right? So let's say if you're predicting stock price, okay? If you're predicting stock price, the most important factors are the earnings of the company, the P by E ratio, the dividends, the performance, the sector, too many things, right? So those are very important factors. But if you take a very, very non-important factor, let's say a weather. So not in most cases it affects the model, okay? In most cases, it does not affect the cost price of the stock, okay? Unless it's really something very weather-related thing, okay? So say, for example, an umbrella, okay? It's a very weather-related, right? So that is the thing. Now, so imagine, this is a very simplistic example. So let's say if you have these three features to determine your grades, how many hours you study, how many hours you sleep, how many hours you spent on extracurricular activities, and what is your grade. So here you have some sample data. So if you study 10 hours, sleep 8 hours, do extracurricular activities 3 hours, your grade is 85 percentage. Okay, so like that, so on and so forth. Now, regular regression, what it will do is it says sleep 2 hours, like average it would come to um, average it'll come to study 2 hours, sleep 1 hour, and the activities is 0.5 hours. What will lasso regression do? How is it different? So see, if you notice, the extracurricular activity does not pay that importance or does not affect that much on the grades. It might to a very minor extent, but it's not a major player. So then lasso regression just simplifies it and takes into consideration only two factors: study hours and sleep hours, and it um, converts its way to 0. Okay, so then this feature is completely ignored. So what you do is hyperparameter lambda you introduce, and you add it as a penalty term. It is also known as L1 penalty because lasso regression is also known as L1 regression. Okay, so hyperparameter lambda. Now, variance and bias. So what is variance and bias? Basically, bias is during the training, how close is your line, how close is your regression line to the training data. Variance is how close is your line to the predicted, to the test data. Okay, so you can see it's a large difference between actually what the predicted value, between the predicted values, between the test data and the predicted values, and this is the test data and the predicted value. So there's a difference between variance and bias. Now, here it is, the formula. See, you don't have to actually use the formula, you have to know it, because in real life, when you use Python or any other languages, using MATLAB or any languages for machine learning, for training or testing your model, they already have inbuilt libraries with the lasso function built in. Okay, but this is a conceptual. You should be clear about the concept so that you can, when you pass the parameters to the function and you use the function, you should know what it is doing. Okay, so what you do is, this is your regular cost function. To that, you add a penalty, which is lambda times the slope of the line. Okay, so when lambda is 0, no parameters, which means you're not adding any penalty, right? So if you add 0 to any number, which means you're not adding anything, because 0 plus any number is the same number, right? Which is equal to a regular linear regression. As the penalty increases, more and more coefficients are set to 0. Okay, and so when lambda increases, the bias increases, which means that your predicted values would be a little far away from the test data, okay, during testing. And as lambda decreases, the variance increases, which means the model does not perform well in testing stage. And if the bias increases, the model does not perform well in the training phase. So what are the common applications? They may be ideal in scenarios where high dimensional data sets means data sets which are, or data which is affected by a large number of parameters. Okay, so when number of predictor variables is much larger than the number of observations. Okay, so what does this mean is, you have, let's say, 100 observations available, but then you have 200 features of the data that you're trying to predict. So lasso regression will reduce the non-important features or eliminate the non-important features. Automating feature selections. Okay, so the bias introduced by L1 penalty will artificially shrink the coefficient towards 0. Okay. What are the limitations of lasso? So lasso, basically what is lasso doing? Reducing the multi-collinearity, which means reducing the number of features. But in some scenarios, what happens is, maybe all the features are very important in predicting something. Okay. Now, in that scenario, you cannot use lasso, because lasso will randomly eliminate some features which were very important in prediction. So such kind of models will not perform well when put to real life applications, because certain features were eliminated at the time of training and testing. Okay? So that's the main limitations of lasso regression. Here you go, a sample program, Python program. So here you have sklearn. From sklearn is the Python library. You import lasso, which is the function. The others are simple. So this is nothing but just getting the housing data set and trying to predict the values of the house. But now when you're, this is how you use lasso. See, just one simple line. Okay, instead of using the regular regression, you're using lasso. where you set the alpha equal to 1.0. Alpha is nothing but the penalty factor. 1 is the default value. If you make alpha equal to 0, no features are eliminated, which means you're not adding penalty. As we discussed earlier, when lambda is 0, it's equivalent to a regular expression. Then you fit the model, and then you have some test data, and then you predict, and then you summarize it. But basically, the important thing is how will you use the lasso in real life or in programming. So you have the scikit-learn library, you import linear model, and from there you use the lasso. And this is how you use lasso regression. So that is all it was about lasso regression. Again, just a brief recap. It's a cost function plus the penalty. Okay. So the model might not do as well during training, but it does well in testing and real life. And why we use Lasso? To eliminate non-important features. So this is all about Lasso regression. See you all again in the next class. Thank you for your time. Okay. Happy learning. Bye.